Part B, part 2.
Because the hydrogen iodide made isn't pure and there are side products formed along with it.
Right, good. Any context to the hydrogen iodide not being pure or further reacts or acts as a good reducing agent or gets oxidized to iodine is correct, right? So let's see. We have next.
Yeah.
Let's go with question 17.
K is chloride,
Okay,
and the equation would be NaCl plus H2SO4 reacts to give NaHSO4 plus HCl.
all right.
And of the observation explanation, hydrogen chloride formed is acidic, so it turns damp blue litmus paper red. And the white fumes are due to the HCl2.
Just cut the word bond out of it. HCl is acidic.
HCl is acidic, all right.
All right. Hydrogen chloride is acidic and turns the blue litmus paper red. Okay, moving on. Number 2.
Bromide, K would be bromidine.
You must be talking about L, right?
Yeah. Oh yeah, L, my bad. We did K. Next part, L. So that would be, do we write bromine, Br2 or, wait. Mm, bromidine, right? Br minus.
Okay.
The color of precipitate, bromine, cream precipitate.
Uh-huh. And
And the equation for the reaction. So it would be NaBr plus AgNO3 reacts to give AgBr plus NaNO3. NO3 minus, yeah.
okay, what makes you think it's bromidine?
Because for chloridine, it dissolves in the both concentrated and dilute ammonia solution. And if it was iodide, it would remain insoluble in both. And iodide is the only one which is
So read the line again. Don't you think it hints towards iodide to what you were saying?
wait.
Because if it remains same, or the precipitate forms after
Okay, which
the
remains
addition of
remains. Oh, okay.
So shouldn't it be
Yeah,
iodide,
yeah, iodide. Yeah, 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 iodide.
which changes the
It's
color to of
yellow
precipitate
precipitate.
to yellow? Now you're
Yellow.
right. Okay, let's move on. I understand you'll do the equation correctly, so let's move on to part three.
This would be bromine,
All right,
and the
and the
explanation would
explanation.
be um bromine has a higher boiling point than chlorine because it has more number of electrons, so the intermolecular forces are much more stronger between the bromine molecules.
Good, that's correct. Okay, let's move on. Let's go ahead with it since this is something we haven't done before.
For magnesium chloride, the pH is 6.5,
Uh-huh.
and silicon chloride it was 2, pH 2.
Mm-hmm. And why are you quoting 6.5 for MgCl2?
Yeah, I memorized it. For sodium it's 7, magnesium it's 6.5, aluminium I think is 3, and then
Great.
silicon is 2.
Great. That's very good. I really appreciate that. Okay, moving on.
Yeah,
So, explaining the difference between the two values.
yeah, all right. So magnesium chloride just dissolves, so MgCl2 plus the aqueous. We can write plus aqueous, and then it gives Mg2 plus 2Cl minus.
Perfect.
And for silicon chloride, SiCl4 plus water gives HCl. It will HCl, 4 HCl plus I think SiO2, white solid.
Great. So actually what you're trying to
Yeah,
do is to refer to the simple
then
dissolving
the
of magnesium
hydrogen.
chloride
Yeah,
and hydrolysis of SiCl4.
right.
Make sure you quote in the word hydrolysis somewhere in there. The rest is fine, the perfectly fine. Even if
All
you
right.
don't code hydrolysis, you'll still get full marks. But since you need to explain it in terms of words, as per an addition and aid of the equation, so it's better to use the exact words. Okay.
All right.
So this is very easy. No, this one either too easy, too easy. We almost have all easy questions. Let's solve this C part. This is different and new.
All right. Do I need to solve A and B, or I can solve it without that?
You can solve it without solving A and B. Just let's get to C directly. C1. Without even solving A and B, the very first line of C is pretty helpful to answer these questions. That line says, I quote,
Mm-hmm.
interhalogen compounds like BrCl have similar properties to the halogens. So it must have similar properties to Cl2 or Br2. Keeping that in mind, it's not difficult to start answering from one.
So bromine is a liquid at room temperature, and chlorine is a gas. So, mm,
And if you have something in between, what are the chances? Because we have one atom of
sorry,
chlorine and one of bromine. We have something
so
in
liquid
between. So
most
what are the
likely.
chances? Liquid. Now, trust me, these questions are made easier because you may act in both cases, actually in both directions. You may write gas, you may write a low boiling liquid, or simply a liquid, and that would be all fine.
Mm-hmm.
So
All
that
right.
answers the physical state. What about the explanation?
Explanation. Explain why it is a liquid. Mm, intermolecular forces. The intermolecular forces between. All right, just a minute. Let me think. Like about I explained the intermolecular forces between the Br and BrCl.
Right.
Like according to that,
That would
okay,
be a
so
very good approach.
the intermolecular forces between the BrCl molecules are strong, strong, so they require
No,
greater
they
energy
can't be
to
strong.
pure. Yeah,
What kind of
so
forces do Br2 or Cl2 have?
weak intermolecular forces.
Weak intermolecular, weak van der Waals forces. If I'd be exact, it would be ID forces, right?
Yeah,
So of
IDID
course,
forces, yes.
BrCl is also going to have weak intermolecular or weak van der Waals forces to be exact, ID forces, right?
Oh,
So
okay.
any
Yeah,
context
right,
to
right.
this ID forces or weaker forces will do it. You can connect it to a number of electrons, right? So that would be easier to
Right.
manage. Okay. So number two, color,
Red brown.
red, brown. Good. Now anything in between red or brown or orange would be fine. Orange, brown, red, brown, yellow, brown would work. Okay. You can go from pale to anywhere in between light, dark. That would work because bromine is red brown or deep red that we call it, and chlorine is pale green. So anything in between can work well actually. Okay.
All
So
right.
let's do with this one. D is also good. Let's try D.
Initially, greenish yellow color, the greenish yellow color starts to disappear,
Okay. What else?
and okay, so we'll have iodine forming and KCl. KCl is soluble iodine, and then purple vapor after several minutes.
Purple vapor. What do you think is happening over there?
Displacement reaction.
Okay, good, good. And what would that displacement form?
Potassium chloride plus iodine.
Okay, I want you to do something and remember it for your papers. This is going to really help you. When you were talking about
Mm-hmm.
initial, what you were thinking is that you were thinking about the color of the gas, but not what's going to happen to the solution.
Right.
Okay. Even after we go for several minutes, you still don't think about the solution appropriately. You talk about just ironing. Okay. Don't forget that I taught you something back in the class that if I talk about this and I'll be actually writing the equation to give you a good idea about it. Now, I hope you do understand this is what's going to happen, right? I hope you do understand this
Right.
is gas, this is aqueous, this is also aqueous, and this is solid. Now, this solid will not turn to gaseous form because this is not a very exothermic reaction and we're not heating it up, okay? Either the solid should settle down
Okay.
at the bottom or don't forget, I told you before when we were doing the bonding chapter, iodine is actually insoluble in water. All right. Now, there is a
All
lab
right.
trick that we do which makes it soluble. We know iodine is insoluble in water. It would simply settle down at the bottom and would look like a gray black liquid settling down at the bottom of water. But what we know is that triiodide ion, which is I3 negative, is soluble in water. All right. And this gives us a yellow brown color. Okay. Since there is some iodide ion present in the system, as soon as it starts producing iodine, these two can interact to form this. Actually, I2 plus I negative gives us I3 negative, which is yellow brown. This is solid, this is aqueous, and let me tell you,
Uh-huh.
this is also aqueous. Now, this is a neat trick that lab people, teachers, maybe the lab attendant, they commonly do in order to solve iodine into a water-based solvent, or simply speaking, water. All right. So, keeping this in mind, this would give you
All
the
right.
idea that initially this system is supposed to give you the yellow brown color because initially we'd have some of the iodide ions and I2 both in the system. But after several minutes, since all of the iodide ions would be converted into I2, sorry, this should go this way, then there should be just dark black liquid, sorry, gray black liquid, not dark black, gray black liquid sitting at the bottom of the solution. Gray black solid. I've been saying liquid a couple of times now.
All
Gray
right,
black
solid.
solid sitting at the bottom of the solution.
All right.
All right. Now, I hope
Yeah.
this also explains why you were getting diagrams of yellow brown liquid back in IGCSE book when you were treating iodine, and iodine has nothing to do with yellow brown color. It's actually the triiodine that was forming. So this
Hmm.
is not still not a part of your book. You're not supposed to explain this to the examiner, but what you are supposed to do is to know that it's going to be yellow brown or the gray black solid, not the dark one, gray black solid.
All right.
Okay, so this is for your own understanding why this is a there is a yellow brown color. You don't need to explain this to the examiner. You simply need to remember the color. That's all what we require both in IGCSE and A levels. So there is
All
no
right.
discussion of triiodide in the book. Okay. And you're going to do the same. Now, this also helps you with paper three. In paper three, there are parts or past papers which include dissolving iodine in water. And we really can't dissolve iodine directly into water. So, what do? We actually take water and we actually add a little bit of Ki in water and then we throw in some iodine pellets, which are usually of this size of dark black solid, and then those pellets dissolve. They actually don't dissolve in water. They react with iodide ions to form triiodide. Okay, so this is
All
what
right.
we do in lab in paper three. Now, the whole information is not a part of your paper theoretically, but the color change is. Also, the trick is a part of paper three's information that a student needs to know because he or she needs to know how to dissolve iodine into water. Okay,
All right.
good. So, we already know what the equation is. Let's directly jump to part three. Now, part three is something which you are supposed to do out of your common sense. We haven't taught part three. We're not going to teach every compound like that, but we did give you an idea what's going to happen.
So chlorine and bromine both can replace iodine and potassium iodide,
Exactly.
right?
Displace, not replace. And
Yeah,
your
displace.
answer is
So
perfectly correct. Chlorine and bromine can both displace it. So what would the equation be?
BrCl plus Ki reacts to give KCl plus KBr and then plus iodine I2.
Perfect. Perfect. Good. So what about four?
As oxidizing agents.
Great. Okay, let's see what we have next. Too easy. Repetition. Easy, easy. Repetition, repetition. Let's try this one out. Slightly different. Not completely,
Oh,
but slightly different.
sodium bromide.
Right. And how did you guess it was sodium bromide?
The orange color, and bromine has a red brown color liquid,
Good.
which is in the gaseous form.
All right. Part B.
Bromine gas,
All right. What else? I mean, C.
it's because Phosphorus 5 oxide is a weaker oxidizing agent, so it won't react with the hydrogen halides.
Phosphorus 5 acid, not oxide.
Acid, yeah, acid.
Yeah, and rest is correct. Good. Phosphorus 5 acid is a weaker oxidizing agent as compared to concentrated sulfuric acid. So the reaction would stop at HX and it won't be further oxidized to any other product. Great.
Yeah.
Oh, that finishes the whole